And welcome everybody to the Daily Space Weather. We were in a brief geomagnetic storm condition, although it's now waned. I'm going to be talking about a tera-electron-volt blazar and a meme drop. I'm your host, Dan, aka smAsho. And thanks for tuning in, all of you stargazers out there. First thing we're doing is looking at the sun in Colorized Magnetogram from the SDO. Is your future so bright you've got to wear shades? So we've got some sunspots, such as 2797, which is this one here, and sunspot 2799, which is just about to set by tomorrow. 2799 will not be visible anymore. Pretty weak solar activity overall here. And here we're showing you the colorized magnetogram again, but also adding the 171 angstroms view. One of the iron ionized emission spectral states. The UV emissions from ionized iron. The radial flux is at 77, and the 10.7 centimeter radial flux is a measurement of the power of the outer coronal radio output. It outputs radio frequency at 2,800 megahertz, or 10.7 centimeters. There's the one-year chart to put it in context, and here's me vanishing. That chart's available at solon.info. And here we are in the Space Weather Enthusiast dashboard, showing you sunspot number progression. And the radial flux going back to about 2009. Next, we'll take a look at what's going on from Lagrange point 5 at stereo A. And not a lot, but there is still a significant possibility of coronal mass ejections. And I don't know why it's not playing. There we go. There's the animated version of it. And what we're talking about here is this, not that, this long plasma plume here. That does have the ability to eject without any solar flares. It's something to keep an eye on. And when I say eye on, well, the pun is intentional. Now let's go take a look at Lagrange point 1 while we're looking at spacecraft. Here is the view from the LASCO C3 rather. And I just wanted to briefly show this as you get to see Saturn and Jupiter. Great view there from the LASCO C3 of those two gas giants, the two largest planets in the solar system. Here's a diagram of the solar system. We'll advance it 1 week. Enough to make you say, oh my God, there are shapes forming. Look at, we still have this Dorito shape in between the Sun, the Earth, Jupiter, and Uranus. Please know the distinction between your hole and Uranus. Coronal holes on Uranus, Moloch, and other made-up demonic entities. There's nothing scarier than an isosceles triangle. And here at the Smash News Network, we regularly make sure that you know how scary and spooky shapes are. Next, looking at a star chart. And the moon's just about to set where I'm located. I like to draw in the ecliptic, and I like to use in-the-sky.org. If you're watching in-the-sky.org, drop me a line. We'll make a video. We've got some great HelioViewer movies, as we do most days. Let's animate that 304 angstroms sun. And here is the sun in the 304 angstroms UV emissions of ionized helium. A little bit of filamentary activity there in the northeast. And again, there's a whole bunch of plasma in between Earth and Sun that's not visible from this view. That's why we show you stereo A on the regs. Next, looking at the magnetogram. It should give us insight into how the sunspots and active regions are progressing, and they've remained quite stable here over the past 24 hours, although there is a new active region forming right here. A little bit of magnetic organization happening in that area. Otherwise, not a lot to comment on. Here's 171 angstroms, one of the UV emission spectral states of ionized iron. And we'll show you one more full disk image here. Here's 193 angstroms. Significant, well-defined coronal hole there in the southeast. And we'll show you close-ups of that at the end of the video. Before that, we're going to do cosmology segment, as there are two interesting stories here from phys.org in the astronomy and space section. But before we do that, we're going to go over volcanoes and earthquakes, a regular feature here at the Smash News Network. Least busted name in news, as I don't have an agenda unless you consider the truth, reality, and actual science an agenda. Sakurajima is erupting. That's located on the Japanese island of Kyushu. It's producing a 5,000-foot plume of ash. Dakono is producing a 5,000-foot plume of ash as well. Popocatépetl, 19,000-foot ash plume there. Fuego, 15,000-foot ash plume as it explodes as well. Sangay also exploding, 20,000-foot ash plume. And while we're unable to detect whether or not Sabancaya down in Peru is erupting, please do not attempt to pole vault the caldera. We need the YouTube views. We did see a small earthquake swarm here around Fiji and Tonga. As you can see there on the map, at least 5 earthquakes happened right in that close region. And some deep quakes kicking off here as well. Here are 2 deep quakes within 5 minutes of each other. This 4.5 at Papua New Guinea was at 200 kilometers, and this 4.4 at Taiwan was at 100 kilometers. Only 5 minutes apart. And then 20 minutes later, another deep quake at Tonga at 506 kilometers. So no quakes over a 6 magnitude here. A few in the 5 range. Some deep quakes there going back closer to 24 hours ago. Here's a deep quake in the Philippines, a 4.4 magnitude. Here's a deep quake in Western South America, in Argentina, a 4.5 at 211 kilometers depth. Here's a 4.6 at depth at Guam, nearly 200 kilometers depth in terms of that 4.6 magnitude quake. A very deep quake strikes Fiji at 1:30 Universal Time this morning. A 4.9 magnitude quake at 577 kilometers. That's a deep one. Here's another deep one. So a significant deep quake event here, folks. A 4.4 magnitude at Timor-Leste at 391 kilometers. A 4.2 magnitude at Chile. That came in at 4:01 Universal Time this morning. Depth is 136.5 kilometers. Another deep quake strikes Fiji just a couple of hours ago there, a 5.0 at 528 kilometers. So deep quake event kicking off there for the past 24. Lots of deep quakes. Next, we've got the real-time solar wind, and we're showing you a 7-day chart here. And the reason that we got into geomagnetic storm conditions is because the solar wind made it up over 620 kilometers per second there, while the density remained steady. The signature of a solar coronal hole high-speed wind stream. So there you go. Current conditions are around 8 protons per cubic centimeter in terms of the solar wind density. Solar wind speed now off its highs down to 550 kilometers a second, which is still an elevated condition. And we can expect this coronal hole wind stream to subside here. And there's the KP index, which has indeed subsided as well. Here at the Smash News Network, least busted name in news, we cover it daily. Current conditions are a KP of 2. And the KP index is a measurement of global geomagnetism. Next, we're going to show the geospace magnetosphere movies, and we see quite a dense region here around the Earth. And you can see denser areas there shown in dark blue, lower density shown in white. And we'll also show you the pressure. There is the pressure. And what you're looking at here is a 90-degree flipped view. One would be as if you're looking downward on, like from the pole. That's the equatorial plane. And the other one is if you're looking at the Earth from the side. Either way, the sun would be to your left. Here are ground magnetic perturbations, and we see significant ones here over the Canadian North Pole, coming out of the Pacific Ocean, coming out of the South Pole region, which, by the way, the South Pole is someplace down here, well off of the Antarctic continent, someplace south of Australia. I'll let it play through a second time as we see significant delta B, meaning changes in the Earth's B field. This is measured in nanopascals, rather nanotesla. Changes in the Earth's B field. Here's a polar view as well. And auroras would have likely already subsided here. Although we expect to see some pretty good photos and videos of auroras in the next couple of days here, as again, there was a geomagnetic storm caused by that coronal hole. So here's the Aurora Forecast. We just figured we'd play it since there was geomagnetic storm condition shown on the KP index for today's daily space weather. And you can find all of this stuff at the bottom of the Space Weather Enthusiast dashboard, the Geospace Magnetosphere movies. Lots of links to show lots of data. The question is, do you understand the physics of how it relates? It's part of the reason why we have a channel, and indeed a website. And it's part of the reason why we do cosmology segments. Because, well, there's a lot of interesting science. And here at the Smash News Network, we're interested in said science. Now today we have no reason to roll any quantum dice because we've got 2 interesting stories from phys.org's Astronomy and Space section. Magnetic waves explain mystery of sun's outer layer. What causes the solar wind to accelerate? Why does it get so hot? Well, one of the theories is that magnetic layers are causing separation of chemicals. In other words, ions get separated into one layer, neutral chemicals get separated into a different layer. And that's basically what the article is about. You can read all about that if you like at phys.org's Astronomy and Space section. Quote, identifying the processes that shape the corona is crucial as we attempt to better understand the solar wind, a stream of charged particles flowing outward from the sun, which can disrupt and damage satellites and infrastructure on Earth. Our new findings will help us analyze the solar wind and trace it back to where it's coming from in the sun's atmosphere. So yes, the existence of magnetic waves, vibrations of ions traveling in a certain direction, were first theorized in 1942 and are thought to be generated by the millions of nanoflares or mini explosions taking place in the corona each second. We're not going to say the word double layer because it will anger and blaspheme the science. So check out that article. Also, we're going to talk briefly about PKS 2155-304, a BL Lacertae object, which is showing some proportional oddities in the hard versus soft X-ray bands. So basically what's going on here is there is some sort of a relationship between its hard and soft X-ray output. and perhaps that gives us some insight into the physics of how these objects operate. So the Blazar PKS 2155-304 can be viewed on the Neil Gorell Swift Bat X-ray Observatory. Here it is on the Fermi Gamma Ray Observatory, and you can see it's a significant gamma ray source, huge cloud of area there in gamma ray. It also shows up on the XMM Newton, Blazar QSO B2155-304. And let's take a look at it in the 2MASS as well. Here it is in infrared light. A Blazar, which is an object which has its pole pointed directly to you, the viewer on Earth. You can also follow it on the Neil Gorell Swift Bat X-ray Observatory. There are the transient outputs, and it's actually gone back into a quiescent state here in the past couple days. It was in burst mode right around New Year's Eve. How about that? By the way, this is the brightest object in UV and in, I think in gamma ray? Hold on. In the southern hemisphere, this Blazar PKS 2155-304 is actually the brightest. It's probably on the screen right now, but I'm failing to see it. Anyway, we've now scrolled the whole article. It's the brightest object in ultraviolet and in X-ray bands in the southern hemisphere. So it's a pretty important object there. Blazar PKS 2155-304. The Tera Electron Volt Blazar that we listed in the title. If you want to follow your favorite transients, such as, Sagittarius A star or Cygnus X1, the first object believed to be a, quote, black hole, which we always refer to as a massive radio source, check out the Neil Gorell Swift Observatory. That's today's cosmology segment, a regular feature here at the Smash News Network. And this one will be just integrated into the Daily Space Weather video. We would also invite you to check us out on Twitter. I did a massive Bernie Sanders meme drop yesterday, and we've been repeatedly dropping this Fauci is a fraud meme since Fauci committed fraud, fraud being the misrepresentation of material facts intentionally, since Fauci intentionally misrepresented material facts. So check us out on Twitter. We've lost another 3 followers since yesterday, and I guess that's probably a badge of honor. There are only 2 more days to answer our poll. So the poll is, what was the biggest fraud in 2020? Was it masks and lockdowns work? Was it that your vote counts? Was it the Fauci herd immunity fraud featured in our Fauci meme? And that's going on a shirt pretty soon, by the way. Or was it the COVID-19 mortality rate? Let us know what you think by answering our poll, twitter.com/smashomash. We've also done a massive meme dump at the forum, smashomash.com/forum. So welcome to the Neo-Renaissance. We invite you to visit our own website, smashomash.com, smashomash.org. You can find the social media links right there behind my head. There you go. And you can also find links. Don't forget to check out our new merch shop, SmAsho Merch. It might be a little bit edgier. And we'd like to commemorate the Dimension of the Year, 2020, a.k.a. 1984, the Dimension of the Year, Hell, as the U.S. gets hurled into an ever-deepening and darkening abyss of dastardly, dim-witted Democrat douchebaggery. If you'd like it on a shirt, well, it now exists. The Dimension of the Year, 2020, commemorate it by advertising it on our shirt. It's also got the website, by the way, down here in the lower right, because I take credit for my works. Also, you can find this design in various different things. Google defined, yes, to use the Google search engine to obtain biased information about someone or something on the World Wide Web. To use it in a sentence, I Googled it, and now I know less about it. Thanks to our subscribers over on Twitter. We're currently streaming live. Twitch. Twitch.tv/SmashOmash. smAsho. Thanks everybody for tuning in over at Twitch. Thanks to our new followers, etc. They've got a great mobile app, and the streaming platform is fantastic. And if you're viewing on YouTube, please don't forget to press like and subscribe over here. Share with your friends, foes, science noobs, and science pros. We've got a lot of things to do, and the more viewers that we get, the better. Thanks to our new subscribers over at YouTube. In all seriousness, cheers. Press the notification bell as well. And again, press share. Share in your social media, especially if you're an influencer. Check out our playlists. Thanks to our new followers, subscribers, whatever you want to call them, over at BitChute, bitchute.com/smAsho. More exclusive content coming there soon, and lots of exclusive content at patreon.com/smAsho for our patrons, the real source of funding for the content. While we make almost nothing on YouTube for the videos, our patrons ensure that we are provided financial incentive to continue making these videos free and publicly visible. So please consider becoming a patron at patreon.com/smAsho. Cheers to our patrons, and thanks very much. Please consider giving Smash staff a raise, as Smash staff is paid a percentage of our Patreon income as well. Again, patreon.com/smAsho. We update the credit crawl every month, and it is in order of lifetime contribution. Here's a quick diagram of the atmosphere. And we're mainly showing this because it shows you the F layer. This is one of NASA's diagrams. It's also showing you electromagnetic penetration through the atmospheric layers, and things like the temperature of the thermosphere at solar max versus solar minimum. By the way, we're just moving into the cool temperature portion of the solar cycle. The thermosphere finally warming up, and it never got quite as cold as it did at the transition between cycle 23 and cycle 24, just like cosmic ray flux was not as high at the transition between cycle 24 and 25 as it was at the transition between cycle 23 and cycle 24. If you see the red F over there on the right side, that red F, it's like right there or something. That's the F ionosphere layer where the GOES 16 makes its measurements. And we don't see any major solar flares, although a B-class flare has kicked off as we did the live stream. Hi, Sun, if you've got comments for the Sun. Hey, thanks there, Sun. Please leave comments directly for the Sun in the comments. Perhaps we'll read them at a later time. We do read all your comments, by the way, and thanks to everybody who leaves comments, views the live premieres, etc. We don't see any proton strikes. There's the 3-day chart of the proton flux. No coronal mass ejections striking the Earth lately. Just coronal hole wind streams. Here's the GOES magnetometer over the past 3 days, and you can see it's quite spiky. The Earth is remaining in the North Pole current sheet as we forecasted yesterday. And here's a diagram of that. It's the top view ecliptic plane field plot, part of the National Sunspot Observatory's Gong 2 data. This data is 1 hour and 46 minutes old. The green current sheet there, that's the North Pole oriented current sheet in which the Earth's potential field surface source line lies. And I would say tomorrow the Earth will remain in the North Pole current sheet, although it could snap across and the magnetic environment can suddenly change with absolutely no warning. It's part of the reason why we have a channel. And here's the line of sight coronal hole plot. And you can see that very well-defined South Pole-oriented coronal hole is affecting the B field there. And the B field in this image is shown in blue. Here's another image of the same basic data. This one is also showing you the solar magnetogram and the poloidal fields. The fields coming from the poles, known as the poloidal fields, not to be confused with this field, which is a toroidal field, the one in which you live. Don't get them confused. And if you want to learn more about toroidal and poloidal fields, check out our playlists at youtube.com/smAsho/playlists. There is a cosmology segment, maybe even 2, dedicated to poloidal versus toroidal fields. And here is a diagram of the solar corona, the atmosphere of the sun, a very chaotic place. And we feature this daily as well here at the Smash News Network. Least busted name in news. Next, looking at the ionosphere. Ionosphere looking pretty charged up here, actually. And we are expecting an increase in the electron flux. We'll talk about it momentarily. Let's bring up the latest image. Ionosphere is pretty charged up here, heavily charged up, actually. Although they're at the current image at 945, looking pretty normal. So here you can see NOAA is forecasting an increase in the electron flux, and I would concur with that. And you can see that I was actually pretty much correct with yesterday's forecast for the electron flux to be a little bit lower than NOAA forecasted it. The green squares are the forecast, and the yellow diamonds are the observations. Here's a 3-day chart of the electron flux. And we typically see this crater when we see coronal hole wind streams. It actually stayed at more nominal levels here during this previous. Actually, it's an ongoing coronal hole wind stream, as it's still striking the magnetosphere now with that approximately 550 kilometer per second solar wind. Here's a visualization of the inner Van Allen belt, essentially. It's showing you the electron density in between your GPS satellite and your GPS handset. And we can expect this to look a little more organized when the electron flux increases. And here's a 1-day chart of the electron flux courtesy Solon.info to put it all in context. Next, we'll look at some meteorological stuff. Another thing that we cover daily here at the Smash News Network. And I'm just checking the life of the stream right now, not just bragging about the quality and non-busted nature of the Smash News Network. Least busted name in news. So here are the jet streams of the eastern world. Here are the jet streams of the western world. And if you had to look at only one piece of weather data from a planetary perspective, the jet stream might be the best. At nullschool.net, we use the 250 hectopascal to infer where the jet stream might be located. We still have an anticyclone here in between Greenland and northern Canada. You can see that clockwise rotation there, east of Greenland. And some extreme bends here. Extreme bends in the southern hemisphere jet stream off the west coast of South America. Let's look at some more meteorology stuff. Check out the NASA GOES lightning mapper. Massive band of lightning here stretching from Mississippi all the way up into North Carolina. And here's a real-time lightning map. And since we're seeing terrestrial strikes in the U.S., hey, Raleigh, get out and look to your southeast. You've got some major lightning down there. Hey, Sanford, there's thunder rolling in. I like to use lightningmaps.org when I hear thunder to convince my foes, and sometimes even my friends, that I'm Thor and that I'm actually causing the thunder. It's good times. Next, looking at the Doppler radar map, and we see a wintry mix approaching my area. Not a fan of driving in freezing rain, which could be a real prospect today. It should be great fun. Significant snow across the north central plains there. Almost the entire state of Iowa seeing some heavy bands of snow, as well as southern Wisconsin, northern Illinois, and southern Michigan especially. Also some heavy snows in places like southern New Mexico and southern Arizona. Not the most normal places for snowfall there. And let's look at the forecast. Here's the forecast for my area. And I've just clicked on something that I didn't want to click on. It's windy.com, by the way. And just checking to see. Only forecasting less than 2 inches of snow here. Let's hope we don't see an ice accumulation. And we'll zoom this out. Now keep in mind, folks, and thanks for noting yesterday, Brett, that we're looking at snow depth here. This shows snow that's already on the ground. We're going to advance this into Thursday. There's where things will be at Thursday at 1 p.m. Eastern Time, according to the Aurora Forecast, which is what you can use to forecast snow depth at windy.com. And they got a great mobile app as well. You may want to consider downloading that. And we're just going to show you the GFS forecast here on Tropical Tidbits. We don't always show it, but today we will. And this is the all precipitation forecast on GFS. So this system in the mid-Atlantic states is expected to move through pretty quickly here. But it is expected to drop some significant wintry mix. It could be a freezing rain situation as we've got very cold ground. And when you get cold ground coupled with warm air, this southerly flow here, this flow from the south rather, more of a northeasterly flow, but in any case, that's the GFS forecast. And we've left the timestamps visible there for you. Next, looking at the water vapor situation over the Americas. Great animated map for you there. Allow me to vanish and let this thing continue to scroll. And let me just check the life of the stream before we move on. We're almost ready to show our other HelioViewer movies. Here is what's going on in the cloud layer. And we've got nearly a continuous line of clouds all the way from Delaware to the Baja California area, as well as an interesting formation over here right near the Four Corners. Here's what's going on in water vapor. And you can see that atmospheric pond moving over the Great Salt Lake right now. It's an atmospheric pond as it's stagnating. And it's time for bonus features. Again, check out our playlists. Don't forget to press like and subscribe if you're viewing on YouTube. Press the share button, share on your social media. Again, we remind you, tell your friends, foes, science noobs, and science pros. And thanks, Smash Team. Here come the bonus features, which will be the colorized magnetogram and the intensitygram of our local yellow dwarf, my favorite star. So here's colorized magnetogram. Check it out. We have a donut-shaped feature here. You don't see that every day. That's sunspot 2797. Here's sunspot 2799 in a setting mode. We may have a sunspot forming there in the north. That active region was not a sunspot last I checked. And let's look at the intensitygram. Here's sunspot 2797, which looks like it's actually grown a little bit since yesterday. There's 2799, which is almost completely out of view. And this could be a new sunspot forming right here. If so, that would be sunspot 2780. 2800. Sunspot 2799. Sunspot 2800, yes. So that could be sunspot 27800. That's something to keep an eye on throughout the day. And when I say eye on, well, the pun is, you get the idea. So we're going back to 193 angstroms. And we've got great HelioViewer movies for you here. Let me bring those up before we close out today's daily space weather at the Smash News Network. So here's 193 angstroms. We're going to show you a close-up of the southern hemisphere and a close-up of that coronal hole, that South Pole-oriented one. The one that's affecting the magnetic field of the local yellow dwarf. Or perhaps it is the magnetic field of the local yellow dwarf. In any case, there's the southern hemisphere. And here's a close-up. And 193 angstroms and 211 angstroms are the best for viewing coronal holes. And let me just pause this for a quick moment. Coronal holes have streams of hydrogen nuclei blasting out of them. Were you aware? This could be geoaffective, and we'll be keeping an eye on that as well, as coronal holes give us insight into the solar cycles, we think. Here's the northern region. Great view of sunspot 2799, those active regions in the north, as well as the north solar polar coronal hole. And we've got some more extreme close-ups. Here's 2799 as it sets. Great view of that. We've got a couple more wavelengths. Here's 131 angstroms, a crowd favorite. And we'll close things out with 171 angstroms. My favorite. In any case, thanks for tuning in. Don't forget to stare at the sun, use the proper instruments, attempt to understand the physics. Visit us on social media, visit our links, etc. Become a patron, support the channel, buy some merch. Give smAsho staff a raise. She gets paid for merch as well, by the way. Welcome to the Neo-Renaissance, and since it'll never be now again, may that solar wind be at your back, and that ice not beneath your tires.